This particular lecture series is about how to make a small electronic equipment prototype in a small setting like your college, your work spot, or even at home, or in case you are a school student or just a curious person in the small workshop or normal places which you have access. Thing is, all formal prototype making involves two different activities. One of the first activities, how to conceptualize a product, saying what is the product, how is it used, and what do we do with it, and so on, and what exactly the product is supposed to perform. Okay, now kindly look at my presentation. So, the small presentation is all about how to make for a small electronic project, how to make fast, low cost, accurate prototypes using available resources. So, next slide is going to show you why do we need to have a prototype at all. To start with, an electronic schematic is converted to a printed wiring board. Contrary to normal usage, the word printed wiring board is more generic. So, even if you are to take a small item like a what do you call remote control, or an item like a small power supply, all of them consist of small electronic components all put on a schematic, arranged as per a schematic, and some logical way depending on a circuit diagram, this schematic shows how these things are to be interconnected. So, when you interconnect them, one of the simple thing is, for example, if you have a resistor, obviously you have 2 leads, and you have an active device like a transistor, you have 3 leads. So, the thing shows you about how to connect a transistor. That is what the schematic diagram is about. Now, the thing is, in reality it is slightly different. So, I will just try to show here. You see here, I have here what, pardon me for my ignorance, what looks like a transistor. I hope it is a transistor. There is something, there is a circle and something, then you have a positive rail, then you have another rail, and then you have a gate here. As if things are not enough, usually you will have some resistors, and here you can probably have a load, and you can have something and all that. Like this, everything is, this whole thing is analyzed, each value of each of these things is determined usually by some sort of a circuit analysis. So, I am just removing it to avoid the clutter here. So, as electronics engineers, I am sure you will know about a lot about this, saying what is a circuit diagram and then what is a schematic, and at some level probably this is already given out by the manufacturer, is it from a textbook or it is from an earlier report, or you have tried it yourself. And for every device or directly on the internet, you have a lot of resources are available on how to connect the schematics together. Now comes the important thing, why we need a prototype. Obviously, everything here, the full thing cannot be put onto one PCB. If you put it in one printed wiring board, there are certain advantages, there are several disadvantages. One of the thing is, simple repair is not possible, and not easy to put together a simple prototype. For example, let us say you would like to make a device which already uses a USB power input. Typically all USBs are about 5 volts, and if it is connected along to a normal PC or anything, around 350 to 400 milliamps can be taken. However, if you take the connector which is called micro USB or type C or anything, connector itself is capable of taking shocking amount of power. Several of them are capable very much of taking 10 amps into 5 volts, 50 watts, but for a extremely short duration. Now comes that thing. So, what will you do with the power supply? Do you now take it out of that unit you want to do, or you would like to incorporate it into the unit itself, or latest fashion is try to use a battery, charge a battery, and battery can be a single cell or battery can be multiple cells. So, by default with this usual lithium ion, lithium polymer, nickel metal hydride, most of them already come with 3.7 volts, which has become a standard. So, everything finally needs to be split into sub assemblies. Having done this, the basic working circuit is ready for us, but unfortunately real life is that so called power supply is telling you the clips are required. Then a little while back I mentioned to you that a connector is required. Connector can be anything. In the case of a mobile, you have something, that 3.5 mm audio connector. So, 3.5 audio connector is just an opening. Their original ones just had 2 contacts inside, and later on things started having 3 contacts by which you could have stereo. Then later on it became 4 contacts by which an extra contact was used also as part of the microphone. Now you see here we have these connectors which play an important role. Now we have several decisions to be taken saying, does this connector go on the external case or does it go as part of the printed wiring board? So even today both options are available. All options, that is, you can even mount them on the printed wiring board or alternately can put them in the case. That is where to take a decision you just need to put everything together at least the first time. Now there are other hardware other than this connectors and all. We have control elements which are typically switches. Control elements can be key. Key means something you press. Switch is usually a toggling device. Then you have potentiometers. Then you have small rotary knobs and all that. All this suddenly you will see that what was a simple, extremely simple, this is a very passive resistor. Suddenly this passive resistor, we end up with a funny thing, one more, seen that. It has become a potentiometer. So, what was having actually only 2 leads, now it ends up with a 3rd lead. So, we end up with all these things saying potentiometers, and then it is now sort of compulsory that you no longer use this type of devices anymore. Why do we don't use it is that leads to a lot of unreliability and noise. So, this so called potentiometer is probably replaced by an electronic voltage controlled some device which has probably keys, a single key or 2 keys and so on. Same thing with the rotary devices, saying, do you have something which you need to rotate? Why do you need rotation? Something has to be increased, decreased, something has to be. A potentiometer can be linear, meaning going in a straight line. A rotary device, something needs to be always circular like this. While these are all come under the category of control elements, we now have several display elements which is part of electronics. pardon me for repeating what look like very elementary simple things, but then the way we treat them, it needs to be told again like that. Most common is dot matrix array. A typical output will probably have an LCD screen, and the simplest LCD screen we can have is a dot matrix array, meaning already there is a predefined characters and each character is made of certain dots. Some of them are, earliest we had 7 segment displays. Now we have 8 into what you call 15, 8 into 16, all sorts of small characters all come in rows. So you have a 20 character display, 40 character display and so on. And the moment you have this dot matrix display, you come into the thing is, difference between all these things are, I think like a dot matrix array or anything else will probably need a transparent window through which we can look at it. And the moment there is a window, now suddenly everything inside is now transferred to the outside. How do we treat that window? Do we need to provide a bezel all around? Do you need to put a mask, or what is it you do there? And we also come with status indicators and warning lights. I think by the English language itself you will know a status indicator shows something is on or off or the status of the thing. Another is a warning saying you are running out of power. So these things invariably form very useful element in the product, like you have this what you call control elements, and then you have display elements, and slightly different thing is this another class of things which can't be put here are the new type of electromechanical devices like buzzers and vibrators. Buzzer is something which buzzes and you can hear the sound. Vibrator is something, usually a small motor fitted to a unbalanced weight which will make things vibrate. So most of your things like these mobiles also come with the vibrator inside. And turning it the other way, suddenly you will notice what I talked to you about all along probably is not relevant anymore, because we have a large display. But running this display and maintaining it, things are superfluous, you do not need it. Best example I can give you is the small Wi-Fi router or switch that you find in your desktop or away from there. It is a small box, you do not need anything. All it requires is a few warning lights, status indicator. Status indicator indicates whether the power is on or not, and a warning light can indicate saying it is out of sync or some other problem is there, and it also indicates whether everything is normal or not. So in a unit like that, every time we need not be forced to give it a big display like that. And last thing, we end up with small cells which are both a boon and a curse. The boon is you can always replace the cell and you are back, and you need not worry anything. The power is a portable power source which is already available for you. So these are very much part of any equipment. Now we will come to the next slide saying why do we need prototyping? That much everybody knows. What I have shown you, everybody knows about it, saying these are all the elements. The laying out of these elements is critical to the success of the product. What started as a simple project of assembling everything together and demonstrating, or we ourselves checking what it is going to be, will now suddenly it needs to become a product. So we do have work to do. Main thing is every product has a function to perform. A little while ago I talked to you about the almost black box, that is the Wi-Fi router. Obviously Wi-Fi router two things it has to do. One of the first thing is it has somehow connect itself to the internet, out to the somewhere, and secondly it has to transform all that signals and all to something which we can use all the time. Seen that, no? That is the basic function of the product. I have taken a router because you are all very familiar with it. Next, if you take a slightly improved one, is probably the remote control which you use for your TV, which is quite common. Then we know that the function is very, what looks obvious sometimes is not necessarily obvious. I am sure you would have felt very frustrated first time you get another remote, saying already I have enough remotes around the house. We have one for the TV, one for the set top box. We also have something else for the audio in case you have a audio device hanging around, and you also have something for the climate control and so on. Plus, if you are one of the early adopters, we have already ended up having remote controls for all the lights, fans and all that. So, though generically all of them come under this thing, the function is defined separately. Next important thing is how usable is the product. You would have felt quite often frustrated when you look at any product, no, you really do not know which button to press, and our friend Murphy is looking around, whatever you press, everything will reset or you will lose the connection. So, this ergonomic consideration saying how do we ergonomically make things hold. Best ergonomic is this mouse. This is a very peculiarly headless, tailless device and continue to be called a mouse. And you see this, everything depends on the position of these things, how well you grasp it, how well you hold things, and then you have several wheels and all that. So, gamer people, young and old, all of them know you probably need one or more extra switches. In contrast, the other what I call Apple never believed in having too much of it, saying one big wad of thing you press and it should work, not even split it, which I think is genius. Ergonomics will tell you how convenient it is for you to operate things, and another thing is we have population stereotypes which we learn all the time. Population stereotype is something to open, something to close, what is left and what is right, how do you drag things, and when you move something up, if when you move the knob up, something has to go up. Will the pointer go up or the screen roll? This is where the ergonomic considerations are very, very critical to a product, saying one is population stereotype, then what about the young people? Young people have changed everything. So, you can't talk about just like that ergonomics. Next we come to positioning of the product determined by the aesthetic considerations. In the core, most products are probably at one level about the same. You understood, no? At one level the basic technology is same and all that. Here positioning refers to product positioning from the marketing point of view. So, just now you gave an example of a game PC, that is also a PC, and then we are all familiar with high power, low power and these things. And if you see the inside of most kiosks and consoles, basically they also have a simple display and a keyboard or anything, but it runs in a different way. It starts up by itself and runs like that. So, this positioning is very, very critical. Now comes the important thing, this prototyping, layout and achieving what is called the aesthetics, ergonomics, functionality, AEF ratio is iterative. That is why we need to make products. Now comes the very critical thing, saying where do we start? In my case, I am using directly material from these professors Ulrich and Eppinger. This whole thing started from MIT, Sloan, and this book is available for you. I suggest as part of the IP or anything, just go and lay your hands on it. If you can get it in your library, it is fine. Alternately, it is available online from anything. Any series is fine. You understand? No, the edition is not important, because what is inside is very important. It is a very, very comprehensive big book. Okay, this many things are there. You see here, right from all the way from introduction, everything it goes here like this. But what we are interested is only this prototyping at this point. Understand? No, because you will soon learn that the same prototyping is used for manufacturing consideration. It is also used for product architecture and industrial design. Industrial design makes products humanly usable. Best example given by industrial design is, if you see any of the machine shop machines, it is practically impossible. The control elements are very, put so far away, it may lead to accidents. And latest is the environment, and something is all about robust design and economics of these things and all that. Coming back to these two people, read a little about it. He is a basically mechanical engineer from MIT. Same thing with Eppinger, professor of engineering systems at MIT, and they put together have put out these books. Their Indian version is available. Similarly, there are other versions, and then it is self-explanatory. What you see here, I will now skip to a little bit of the actual things. You have seen here, in all this every place, you probably need to have a prototype. What looks very simple, saying identifying customer needs, not that easy, not at all easy. So, several of us know that you have a clothes washer at home, fine, but there are too many buttons to press. Then similarly, we have a dishwasher, little tough. Other extreme, I will say, take the case of the microwave oven. In spite of all the options or everything, everybody knows, open the oven, put it, press some button, it starts rotating, and we know it is working. You understand? No? So, usability is very, very easy in those considerations. There is a thing like a microwave, a small microwave can use for reheating, big microwave does something. A very big microwave, usually 40-50 liters thing, can almost replace a regular cooking range. Now, this is where what does the customer want is a big thing. Right now, last about maybe 10-15 years, all fitted kitchens or so called dream kitchens have a microwave just above the cooking range. You understand? No, cooking range, you have all the hobs or burners or anything, you have the microwave just above it. It looked ridiculous, is it not? Dangerous. And the microwave suddenly does something else. You know what it does? It is also the kitchen hood. It extracts all the air above, takes it up and moves it out. I never thought it is possible. I never thought anybody will buy it, but now I see that several places where you go, you have this hob. Under the hob you have the regular oven in which you bake, you braise various things. Above that, at a reasonable height, you have the microwave when we can open and put things, and the bottom of the microwave oven also serves as the hood which takes out all the air. That is exactly what the customer wants, and people have been buying it. If you see it once, you will probably want to buy one immediately, probably for yourself, the others. Now, coming back to my slide here, here comes everything like this. Why all this product design and stuff is required is, one is how to arrange things together, how to make it humanly useful, how to manufacture it, all this depending on customer needs, and somebody has to write this. Finally, the intellectual property which you can hold on to this. So, in all these aspects you must make a prototype. So, a prototype helps to organize the elements of the product internal to the structure, effect on the external interface. So, coming back to the, if you see my mobile, why I am showing this, we all know about it. We all know that probably it makes sense to keep the 3.5 mm jack there, because you can carry it here and make it and all that. You will be surprised now, some of the current new mobiles do not have a jack anymore. Everything has gone Bluetooth, wireless, and I do not even know it is Bluetooth or not, it is at least wireless. So, redundant here, and we all know that probably we need this charging port here. Now, is it logical to keep the charging port here or is it somewhere else? Is it probably logical to keep it here, or best is wireless charging again, you understand, no? We have full wireless charging. So, they are very good mobiles which do not have any of these openings, except by default you have a small speaker there, and in this case we also have a small front camera. A mobile communicator is suddenly a camera, and then nobody carries out those toy cameras in their pocket anymore, because it looks like there is enough processing in this what you call octa-core processor, and you do not need to carry another small this thing, and you end up with something here at the back, that is the once again a camera or dual cameras, and probably a small flash, something which does ranging and fingerprint sensor, and people have tried to remove the fingerprint sensor from there, saying why do not you make it as a capacitive touch, and some are now available without any of these things, because it is face recognition automatically. So, maybe it says you are too old to operate it, so sorry, all features will be disabled for you except for dialing large numbers, everything will be disabled for you. And if you are a small child, no, it says which game do you want to play, intelligence is built into it. So, coming back to my presentation here, we have the effect of all these elements on the external interface and the reverse also. The external interface determines the internal layout and structure, while visible elements I have spoken to you about. A modern new mobile may have a minimum of 5 to 6 antennas to carry out their functions. So, these antennas also have this physical interdependencies, one of the other should not indicate with the, interfere with each other. And finally, how does the mobile feel, touchy feely? If we can make a prototype, it is very much possible. Hopefully, this leads to an optimized offer. So, this whole lecture was only about how to, why a prototype is required. Now comes the important thing, which for this session I will try to carry on to the thing. A proper prototype is of course very, very expensive. Understand, a fully functional evaluative prototype is really expensive, and contrary to the stories you hear, 3D printing is not easily within reach. You can buy a 3D printer, do something, but you can't really do anything with it. Somebody has to critically do the part design, and the manufacturing other person has to vet your design, and still for the first timer is still a trial and error, not really needed for flat geometries. If you want to make a something which is typically a cuboid or a parallelepiped which has 6 faces, not that easy to make these things. Similar way, everybody tells you now, if you can imagine a product and design a product, easily we can make it by computerized machining, which is also not true. This numerical control machines themselves are still a thing. Same thing is with laser cutting also. So, right now I will there seems to be a logical end to this place here. I will stop here, I will repeat the same slide next time and I will continue from there. So, thank you. Allow me to repeat once again that you kindly look for this what I call this book, Product Design and Development. It is available in regular bookshops, you can get it. You can get it online, most likely your library will have it. Do not think this is the only book, several of the other books also cover these things, and if you are one of the people who are now in the modern economy and modern engineering schools, the whole thing about prototyping, how to come out with alternate solutions, how to choose the solutions, how to evaluate, and based on that know which are the ones which you need to go for manufacture is already explained to you. This lecture is going to be only about the lecture series how you can make it without having to seek help outside, meaning with whatever researchers you have you can still make it, is exactly how we were making things 40 years back. In 75, 76 when we started, we were making everything with available materials in a small way. Once you are a little confident that your technology can be demonstrated and there is a place for a product like this with certain features, next you can go in for making a really formal prototype. So, thank you. We will meet again. Thank you.